Welcome back to 7th grade math. This is chapter 7, section 5, nonlinear functions. We get to talk about some things that are nonlinear. If they're nonlinear, they are not what? They're not lines. So everybody show me a line with your arms as best you can. Really, these are just a bunch of segments in the classroom right now because no one has an infinite arm. But we know what you're trying to imagine, an infinite arm in both directions by itself. What does it look like on the backside? I don't know. Okay, so a nonlinear function, we get to try something that's not a line, a function whose graph is not aligned. And so before we do that, let's jot down what we recall the model line, the model linear function. Y equals
mx plus b.
Say it loud. Y equals
mx plus b.
Plus b. That's a giant plus sign right there. Y equals mx plus b. Do you know the simplest linear function? What do you think the simplest slope would be to stick in for m? 1. Good, I hear it. So, and what do you think the simplest y-intercept would be? 0. So there it is. That's called the parent linear function. Y equals x. Parent linear. Which must mean all the other linear functions are the babies, right? Right? What does a parent linear function look like on a graph? Can you show me with your arms? I see some horizontal arms, I see some vertical arms, and then I see some at an angle-ish, which, good for you, Riley, it is an angle. Because think about it, if we look on this coordinate plane here, when x is 0, y would be 0, right? When x is 1, y would be 1, right? When x is 2, y is 2. Do you see how it would look? It looks like direct
Variation.
Good, variation, and it is like a 45-degree angle. Okay, so I should do this for the video folks at home, right? It goes like this. Okay, we have y, x, just a little basic sketch. It's like that. That's the parent linear function. So all of the kinds of functions that we graph in algebra have a most basic one, and that's the most basic one. Okay? Even though horizontal and vertical feel so basic, this one is the parent function. So what I want you to look at in the linear function is the x. That's our input, right? That's our input. What is the exponent here? I don't see one, so the exponent is? Good job, 1. Okay, so that is what makes it linear. When you plug a number into the linear functions, when you plug an x in, you just multiply it to the slope. You don't do anything other than multiply it to the slope and add your y-intercept. Today we're going to move to quadratic functions. It's the next degree up from a linear function. So a linear function's input is raised to the first degree. So a quadratic function input will be raised to the? It feels like 4 because of the prefix quad, but it's not. I wish it wasn't. I wish it was called the quadratic function because the exponent is 2. It's 2. Okay? Whoops, that was supposed to be hidden. Let me do this. I'll hide it. Like that. Okay, so you have a model for the quadratic function. Y equals a times x squared. So you see that the input now, the inputs domain are going to be squared. They're not going to just stay to the first. They're going to be squared. And then we multiply it by something. It feels like, this a feels like slope, doesn't it? There's a number in front of the x squared. And so it's not considered to be slope, but it is a factor that we have. Notice the rule says a may not equal what? 0. What would happen if it did? What is 0 times x squared? 0. And what would, the question is, what would y equals 0 look like? Can you show me with your arms? Y equals 0? All the y's are 0. I see some horizontal lines, I see some vertical lines. Which one is it? Where are all the Y's? 0. No flying, no flying, no flying, right? 0. Aha, horizontal. It's horizontal at the x-axis, isn't it? Okay, so we can't allow a to equal 0 because if we did, we would end up with a line, a linear equation again. Y equals 0. Okay, today we're going to graph these. What was the most basic method we learned for graphing? Hannah, what were you going to say? No, you said something else. I thought I saw you saying something else. Okay, well, there is a more basic way to do that graphing. Please stand and say good morning to me. Okay, so the most basic way of graphing any kind of equation. The first thing we ever did in graphing our lines. The most basic way, Rachel.
Make a table?
Make a table. And that's what we're going to do. We're always going to fall back on that. Make a table. How many points did we recommend? Show me with your hands. How many points did we recommend in a table? I see 3s, I see mostly 5s, and that's right, 5s. 5 points. And so that gives us a nice variety to look at when we gather our ordered pairs, right? So what do you think would be important inputs to consider when you're making this table? Liam? 0. Excellent. What else? Rachel?
-2.
-2. Anyone have another one? Isabel? 1. Okay, so why don't we go with 2 and -1 since you chose those, okay? So good, I like the fact that you have chosen negative values, positive values, and our neutral 0. It's good. So let's go ahead and plug those values into this function and find the range, okay? Max.
Wait, why is it y equals a times x?
What is a in this equation, Max? This is just an equation you've been given to graph. Now, what is the a? When you don't see a number in front of x squared, what is it? The invisible coefficient.
Oh.
It's 1. Good. So it really is there, but we don't show coefficients of 1. We don't have to show them. We all know that at this point, right? So we can just leave it alone, or you can fill a 1 in if you want. Whatever you're comfortable with. Okay? Let's go ahead and plug these values in. Faith, what happens when we plug in 0? What about 1? What about 2? Good. And what happens if we plug in -1? -1. What do you think we get? Alana? If you plug in -1 here, what is -1 times -1? Positive 1, right? 1 times 1. And then what about -2? When you plug it in, remember the whole quantity is plugged in. -2 times -2 is 4. So it's as though there are parentheses including the negative, right? The negative is being squared there. Becomes really important, doesn't it? Because do we have any y values that are negative? No. Good. Okay, so make yourself a graph and graph this. How does a person graph when you have a set of points like this? Nicholas, can you tell us?
So with this, it's x equals y, so you walk -2, and then fly.
Okay, just the way we've graphed every point this year. We walk in the x direction, left or right, and we fly up or down, right? So the second point is -1, walk -1, fly 1. The third point is at 0, 0. The fourth point is at walk 1, fly 1. And the last point is walk 2, fly 4. Okay, so could we put other values in the table? We could. What would happen if I input 3? What would I get? 3 squared is 9. 3, 9. I can put that in there. What if I plugged in -3? -3 would also be 9. I could even plug in halves. What if I plugged in x equals 1/2? What is 1/2 times 1/2? 1/2 times 1/2. 1/4. Good. Plug in 1/2, you get out 1/4. Way down here. Plug in negative 1/2, I get out 1/4. I could plug in infinite x values, and will any of them be negative? Give me negative y's? No. Okay, so we go ahead knowing that this is what it is going to look like. We draw the curve, and the curve is a U-shaped curve. And there you go. Beautiful. Beautiful U-shaped curve. Okay, and who knows the name of this? I think it was written on the previous page, wasn't it? Oh, I hit it. A U-shaped curve begins with a P, and it's called a... I'll be like Father Joseph. It rhymes with parabola.
Parabola.
Parabola, there you go. U-shaped curves called parabolas. I'll write the word for you. P-A-R-A-B-O-L-A. Parabola. U-shaped curves. Okay? Okay, so here is some danger things to look for. When you are graphing parabolas, they should look like what shape? U shape. They may look like an upside down U as well, right? That still looks like a U. So, will you ever have a shape? Let me put some sad face shapes. Sad face shapes. We will never have a shape like this. Is this a U shape? No. And you shouldn't have a U that looks like this. Is that a U shape? No. I mean, if that was to go on, those arrows mean it's going to continue on, right? Doesn't it look like they're going to cross? Mm-hmm. So that's not a U. The U we're talking about never crosses. As you increase putting in values, even in this case here, it's going to get ever further out. Even though it's steep, you're getting ever further wider. Okay? And finally, one other thing before I take questions. Your U shape will not all of a sudden curve out like a beautiful vase. And I bring this up because I see this every year. We don't add little tails or anything like that. They look like a U that's rather straightish on the where the arrows are extended. Okay, Hannah? Let's see what happens when our A changes. What is the value of the A in this quadratic equation? Does everyone see that? What's the number, Max, that comes in front of this one? So the value of A here is -1. Let's make a table. Let's pause the video, make a table, and graph this. Come back and check your work. Yay. Okay, so we have now a U that is upside down because you must square your X and then take the opposite after. This negative is not being squared. It's not in parentheses. So with this upside down U, what was I going to ask? Oh, what caused it to be upside down? What causes a parabola to be upside down? Wesley? Good, the negative A value. Negative A value causes an upside down U. All right, an upside down parabola. Okay? Over here we have a positive A value. 1x squared. It's a right side up U. Upside down U. What will this one be? Will this one be upside down or right side up? Right side up. It's a positive A. So the last job is to go ahead and graph this one, and if you're on video, come back and check your work. Very good. And so we carefully chose a domain that would cancel with our denominator, which you don't have to do, but it's nice to do, to give you integer y values popping out, right? And notice this graph. Would you say this graph is steeper or flatter than the others? What? It's actually a little flatter due to that fraction, okay? We call that a vertical shrink for you advanced people. Here you go. Have a good time. Enjoy your parabolas.